All right, it is time for a new parent function. We're going to take a look at the one called the reciprocal function. I also refer to it frequently as the flip it over function. Basic notation is f of x equals 1 over x. We may add another notation a little bit later when we learn some extra. Actually, we know this already. This can also be written as x to the negative 1. Because that negative 1 power means the same thing as flipping that over. We learned that about the exponents. So, what does this look like here? We can do it as 1 over. We'll frequently see this when the variable quantity is in the denominator and we want to get it down there. This is the function that we use to make that happen. Our key points, we want to know again about end behavior. So left-hand end behavior, and then we'll look at what happens at -1, what happens at 0, what happens at 1, and then the right-hand end behavior. You could fill in certainly with other ones, but these are the key ones to look for. And when we flip over a negative infinity, it goes towards 0. Okay, if we think about 1 divided by the biggest number you can possibly imagine, if you took $1 and split it between the 7.5 billion people that are on the planet, everybody would have basically nothing. 1 divided by -1, we can read it that way too. 1 divided by -1 is -1. I'm going to skip that one for a second. 1 divided by 1 is 1. 1 divided by infinity is 0 as well. 1 divided by 0 is the one that your 4th grade teacher warned you about and said you can't divide by 0. Well, we can't, and there's a way that the graph tells us that. A calculator, if we try to do it, gives us an error. The graph creates what's called a vertical asymptote. This is a new thing for us. And so I'm going to just kind of sketch in there the vertical asymptote. And we'll see what that looks like when we get to sketching things on the graph. So, way out on the left, it is heading towards 0. That was our idea of the horizontal asymptote as an end behavior, but let's plot some other points in here. So we need standard points around here. There's 1, there's the -1, there's a 1 there, there's a -1 there. And the obvious easy points here are the -1, -1. So we have a point right here. And we've got a point at 1, 1. Okay. The vertical asymptote, to help guide us, we're just going to draw a dotted vertical line here. Okay. Calculator won't draw that on there. This is just a guide for us, reminding us that we cannot put a point on that axis anywhere. If we put a point on the axis, then that means there is an input-output pair when the input is 0. And that would imply that if I input a 0 into 1 divided by something, so 1 divided by 0, if I put a dot on that y-axis somewhere, then I've just figured out how to divide by 0 and figured out what the answer is. Okay, but there isn't an answer. Okay, so we can't put that there. So we'll look at the behavior and what it looks like around there. This heading towards 0 here, it is a +1 divided by a negative very large number, so it's getting close to 0, but it is negative. And so this, on the horizontal asymptote out this direction, comes in like this, and it hits that, and then it's actually going to go down like this. Okay, we would be able to see this if we put some other numbers that were small but close to 0, like if I put in a -1/100th. -1/100th, when I flip it over, 1 divided by -1/100 is -100. So when I'm very close to my x-axis here, and I plug those numbers in, I get very big negative numbers down here somewhere. So this is the shape that comes out if I string together all of those possible numbers. On the other side, we're transitioning from inputs that are negative to inputs that are positive. So positive divided by positive is going to be a positive, and this is going to look like that off that direction for the same reason that the other one did on the bottom. And then this is going to go out here, getting closer and closer to 0 out that direction. So we do have our horizontal asymptotes again as in behavior, our in behavior description as x approaches negative infinity, f of x approaches 0. Same thing happening over here as x approaches positive infinity, f of x approaches 0. But now we have this new thing. Okay? This, again, is called a vertical asymptote. You can kind of see that it has some things in common with a horizontal asymptote, but mostly they're very, very different things. Okay. This is going to have something to do with the domain of the problem, and we'll talk about that here in just a second as well. But our description of a vertical asymptote, on this one we would say that as x approaches 0, 0 is where this thing happens, right? Because that's where it was over here in our list. And we're going to put a little negative sign up the front or on the top that says as x approaches 0 from the negative side, from the left-hand side, we can say that f of x, the outputs approach negative infinity. And on the other side of that, we can say that as x approaches 0 on the positive side, then f of x approaches positive infinity. So just kind of shortcut notation for describing this vertical asymptote that we see happening there and is right here and is described by these things in here. Okay. Couple more unique things about this. Let's look at the domain. The domain says, well, we've covered all the numbers except there is no output for 0. So the easiest way to describe this domain is to say x cannot be equal to 0. Because if I do make x 0, then I'm dividing by 0, and my 4th grade teacher or 3rd grade teacher would be very upset about that. Probably 3rd grade for you guys, 4th grade for me. All right. Our range then, if we take a look at this just visually on the range, we can see where that vertical asymptote hits and says that we can't make an x0, but our horizontal asymptotes in here, we're also seeing that those never cross the x-axis, so we're never going to get an output of 0 from this either, so my range is going to be that y cannot equal 0. So we've got restricted domain and restricted range. If you think back to the first unit of this lesson or this chapter, we talked about domain and range, and we should be able to look at that picture and see that those are the restrictions that are in place here. The other unique thing about this, normally I have these parent function pages with 2 on a page because we do 1 and then we do the inverse of that 1 on the same page. The thing here though is if I want to do an inverse, okay, remember the inverse, we're switching the roles here, we're going the other direction, so how do we undo flipping something over? Well, if you think about it, if you flip something over, the way you get it back into its original state is you flip it over again. So this is a function whose inverse is itself. It is its own inverse. Okay, so if you want to undo a flip over, you flip over. And so if we're at a place with an arrow diagram that we need to go backwards, the opposite direction of a reciprocal, then the opposite direction is also a reciprocal. Okay, and we can see that happening here a little bit. This vertical asymptote becoming a zero, to have a vertical then becomes a horizontal, and we have the horizontal asymptote at zero, and the 1 over zeros become heading toward infinite amounts. And so we've got some interesting connections happening on there, and a very unique thing. This is our information about the reciprocal function.